elastic grid service demo. In this demo, we're going to be showing you prioritized preemption of workloads. As a quick reminder, our system manages multiple clusters and looks at all of the GPU resources that live within those clusters. For this demo, we have a far edge, a near edge, and an AI factory. Again, very reflective of a multi-tier architecture that may have inferencing. And within each of those tiers, we have GPU resources that are assigned. And you can see all of the resources are currently allocated. It's going to be kind of tough to run another job in this infrastructure since everything's already busy. But let's see how we can work around that. If we go to look at the AI workloads currently in the system, you'll see that we have a tiered inferencing service that's running across both the far edge and the near edge. This is interesting because this uses our cube slice to connect two different clusters in two different locations with one service and load balancing. Sorry to go off on a tangent, but that's just a cool use case. The other workload running in the system is a batch job. So we have a batch we call a stress test that's running and really stressing out this GPU at 100% utilization. The other thing you'll notice about this particular batch job in our GPU request is that it's running at a pretty low priority, just priority 1. This means that this particular job can be booted off the GPU in preference of a higher priority job. And we'll see exactly how that works. So we've got our dashboard, we've got our current utilization across all 3 of the GPUs in the system. We also have cost tracking, and it's keeping track of all the usage across all the GPUs and workspaces. This is a very handy feature for chargeback, showback. We have our infrastructure health, so we're able to look at power usage, GPU temperatures, GPU memory utilization, as well as time series data on power and temperature as well. And we also maintain a topology diagram. So for instance, in our tiered inference workspace, we can look at the latencies from both the far edge to the near edge or the far edge to the AI factory. These are both in the same cloud, that's why they have very low latency. All right, so back to how do we preempt workloads? We're going to look at what we call GPU request. Now, typically when you run a new workload, you would simply go to your command line, or you'd go to GitOps and you'd launch a new job. So this one is going to go to create a 70 billion Llama 3 model. But if we look at those pods, unfortunately that scheduling is gated, meaning it's not going to execute right now. However, if we go to our GPU request and we go to the large model deployment workspace, we can create a new GPU request. This is all able to be automated through the command line as well, but we're showing you the internal details of how all this comes together. And our Llama 3 70 billion GPR, we give it a name, we tell it the memory that it needs, and then we're going to say pick a GPU and auto select the cluster while you're at it, meaning this is very little to no configuration for actually deciding where this GPU is going to end, where this workload is going to end up, in which GPU. And when we click wait, getting the wait time, we actually have that AI factory GPU showing up as available. There's no wait for it. Even though it's busy right now, it's a low priority job, and our current job is going in at a high priority. So we're not going to have to wait at all for this GPU. And what you'll see is that GPR is going to get created, and immediately it's going to get queued. And then back to our GPU requests, you'll see this, this GPR that's currently provisioned. We're going to watch this, and we're going to see that one go back to a queued state because it's going to take that one offline since we have another GPU ready to go. And as that batch job gets deprioritized, it goes back to queued state. So it'll pick up when we're done our large model deployment. But now our large model deployment is moving into the queued state, and soon that will be provisioned for the Llama 3 model to start running. And there it goes. So that GPU, that H100, has been handed over from the low priority batch job to the high priority inferencing job. Thanks for joining.